Hello, welcome to Calculus AB, the product rule for a derivative on May 20th, 2019. The product rule can be defined by the function which states that the derivative of the product of two functions is equal to the derivative of the first function times the second plus the first times the derivative of the second function. So now we're going to have an example. So we can use the equation in action. So as you can see, the equation we're going to use to guide us is in the top right. So the question is asking us to find the derivative of this 3x squared times the quantity 5x minus 4. So we're just going to use the equation right up there. So the derivative of the first function, which is 3x squared, so we're going to do the derivative of 3x squared is 6x, because 2 times 3 is 6, times just the second function, you don't have to do anything to it, times the second, plus the first function, times the derivative of the second function, and the derivative of 5x minus 4 is just 5. So if we work this out, we get 30x squared minus 24x plus 3 times 5 is 15, so 15x squared, and we can simplify that into 45x squared minus 24x. And that's the answer to our first example. On to the next. So for the next example, we're going to use the same equation, and let's just get right into it. So the derivative of the first term, 4x to the fifth, so that's going to be 20x to the fourth times sine x plus 4x to the fifth, because we don't have to do anything there, times the derivative of the second term, which the derivative of sine x is cosine x. So let's just work this out. So that's 20x to the fourth sine x plus 4x to the fifth cosine x. Nothing much you can do to that now. That's the answer. So before our third example, there's another thing I need to talk about, which is that the product rule can be used for any number of products. So say you have 3 products. All you have to do is the first 2 terms times the derivative of the third plus the first and the third term times the derivative of the second plus the derivative of the first term times the last 2. And you can do this for any number of products. All you have to make sure is that each term is taking a derivative in one of the things you have to take a sum of. So as you, like, for example, we have 4 terms right here. So a, b, c, d. ABC times derivative of d plus AB times derivative of c, d, plus a derivative of b, cd, plus derivative of a times bcd. And we don't really have to do an example of this because you already know how that goes. So the final example. Our final example. The position of a particle is given by the function x of t equals the quantity t squared minus 5t multiplied by cosine t. And we need to find the velocity of the particle at t equals pi. So we know that velocity is the derivative of position. So therefore, we just need to find x prime of t. So that means we need to find the derivative of that right there. So let's use the product rule, which is the derivative of the first times the second term plus the derivative of the second times the first term. So the derivative of the first, which the derivative of t squared minus 5t is 2t minus 5. Let's multiply that by cosine t plus t squared minus 5t times the derivative of cosine t is negative sine t and so let's multiply these. So 2t cosine t minus 5 cosine t plus negative t squared sine t plus 5t sine t. So for this problem, we're going to need our trusty calculator. So if t equals pi, 2 pi cosine pi minus 5 cosine of pi plus negative pi squared sine pi plus 5 pi sine pi. So, if we work that out in our calculator, so if you plug all of that into your calculator, you will get 1.6 meters per second squared, which is your final answer. So, at t equals pi, the particle is moving at 1.6 meters per second squared because we know that velocity is the derivative of position, and we use the product rule to find the derivative of t squared minus 5t multiplied by cosine t, and we plugged in pi. So that's it for this Calculus AB lesson of the product rule. Bye!